This is Lisp for ACSL. Lisp is an archaic programming language that was developed in the 1950s and is tested on the ACSL quiz. Lisp is based on lists, which look as follows in the language. This is a list in the Lisp, with elements 23, this is easy, hello, and 21. Each element of the list is an atom. So at the lowest level, all of the atoms are 23, this is easy, hello, and 821. Notice how the first element is 23 and the second element is the list, this is easy. Even though the list, this is easy, is itself an element, the atoms are still the lowermost elements of the list. So this is easy are elements, but the list, this is easy, is not an atom. So here's a quick note on the single quotations. At a high level, the single quotations mark when something is a literal. And that's important because in Lisp, we need somehow to make the distinction between code and data. So for example, the expression on the left, 1, 2, 3, the code will interpret that as the function 1 with arguments 2 and 3, and we'll try to run it. By including a single quote, we specify that it's in fact a list with atoms 1, 2, and 3. So the single quote means that something is a literal or a piece of data that is not code and should not be executed. If you don't understand that, I would consider Googling it for further, explanation. But generally on the quiz, you don't need to make that clear of a distinction, but it's very important to know if you want to truly understand this language. And especially if you wanted to code in it for whatever reason, you'd need to know how to make the distinction between literals and code. All right, so in Lisp, there are a few extremely important functions for us to know, and we'll go through them right now. We'll start with arithmetic and other similar functions. So if we have add and then a and b, this will evaluate to the sum of a and b. If we have sub a and b, this will evaluate to the subtraction of a minus b. Mult a and b is the multiplication of the two. It evaluates to whatever number a times b is. Div ab is a divided by b. Square a is a times a, or a squared. Exp an is a to the power n, so it's a, and then the exponent here is n, so a to the power n is exp an. Equal, eq equals, obviously it's the first bit of equals, so eqab is true if a and b are equal, and is nil or false otherwise. Pos a is true if a is positive, but is false or nil otherwise. Neg a is the opposite. It's true if a is a negative number, and is nil or false otherwise. So the arithmetic functions can also be written by their signs, plus, minus, divided, and times. So mult a b is the same thing, can be written as just a times b. So there are a few other basic functions in Lisp. The set functions are very good for setting variables and will be or could be used in the ACSL program. So this is just how you set variables to like values. So here in this first one we have set a, so a is a literal, it's a piece of data, not code, and we're setting it to this, and because this here has no quotation mark, we'd evaluate it, so a is 6, because this is code that's to be evaluated, so we do mult 2, 3, that becomes 6, and we set that to a. Here we have set a is a literal, and then we set it to this, which has a quote, so it's a literal. So instead of being code that we evaluate, it's a list with 3 elements, mult 2 and 3. Here we're setting b, which is a literal, to literal a, so b is an atom with the value of a. Now if we were to set c, which is a literal, to a without a quotation mark, well, we already set a here to be mult 2, 3. So because this is code and we're supposed to execute it, C would be an element with mult 2 and 3, or a list with mult 2 and 3 elements. Same thing, set Q here. Set Q just means set with a quote. So here X, if you do set Q, you just don't need to put a quote in front of the variable name. So this is the same thing as set and then quote EX. But by set Q, you don't need to have the quote in front of EX. So the following are the most important functions for ACSL. The first function is car, and this returns the first element of a list X. So if we have car and then X here, which is going to be a list, this returns the first element of that list. So for example, if we have car and then this list, it will take the first element, which is just this. Cdr or CDR returns the list X without the first element, so we'll take everything but the first element. So if we have cdr, this is a list, we simply remove this, and that's what we return. So we get is a list, and this itself is in a list. Whereas before we just took the first value, so it would be this. Cdr just removes the first value from the list. Cons xy returns X as the first element of list Y. So if we have cons red and then white blue, we're going to add red to the list with white and blue in it as the first element. So pretty much we're appending to the front of the list here. That's what cons does. Reverse X reverses the list X. So if we have reverse red, white, and blue, we instead get blue, white, and red. So cdr and cars can be chained up, and as such are frequently abbreviated. So C, D, D, A, D, A, A, R is actually, we can look between the C and the R to see what to do. So this first D becomes cdr, this next D becomes a cdr, this A becomes a car, then we get a cdr, a car, and a car. So this is an abbreviation for all of these chained up. And when you actually look at the parentheses, you'd go from this car, you do this first, then this car, then this cdr, then this car, then this cdr, then this cdr, and then you will have evaluated this whole thing, which is an abbreviation for all of these. So let's go through some example questions now. So first you want to evaluate this. Well, we know that car simply returns the first element. So here we're going to see this list here, and the first element of this list is this list right here. 2, and then 3, which itself is in a list, so that's the answer. Now we want to evaluate this. So we're setting X to this list here, and then we want to evaluate this. So we're going to reverse this list, so we can look at it, pretend that this is the first element. We're going to cdr this list, so we're going to remove TX, and then we're going to take the first element. So the answer should be CA. So we're going to, we can look at the steps here. Car cdr reverse of X, which is car cdr reverse of this whole list. So car cdr of the reverse list. Then we remove the TX for the cdr, and then we get car of this list, and the answer is just CA. So again, that's the solution. It binds the variable X to this list. We reverse it, we car it, we cdr it in the order they ask us to. All right, so here this is just arithmetic question. So what we're going to do first is we're going to look actually at the deepest parentheses because that's what we need to do. So sub 25 is what we evaluate first, along with this addition and this multiplication. So we would get mult 11, this becomes 11, this multiplication becomes 20, and this substitution becomes minus 3. So we have multiply 11, 20, and then we need to evaluate this division because it's in the deepest parentheses. So that becomes minus 2, and then we have this mult 11, 20, minus 2, which becomes minus 440. All right, that's it for this video. If you have any questions, consider reading the wiki. Remember to do the practice problems, and of course, if you still are having trouble, reach out to a senior member of the team for assistance. Thank you very much, and good luck.